record this. Okay. Yes, exponential and log form are inverses. So how would I rewrite this to be in log form? What about log? Yeah, we need log for sure. Log base what? 2 of 8 equals... Perfect. Perfect, McKenna. I love it. Okay. Log base 2 of 8 equals 3. Now, the second one. How am I going to rewrite that? Log of equals perfect. You have to know this. You have to know how to go back and forth between these two forms. Okay, that is something that is so important for this unit because it's in so many problems. Okay, so please make sure we know that. Okay, any questions? All right, let's get rocking and rolling. We're diving into 5.3. So this is going to be our first day of solving, okay? And this is going to be solving what we call exponential equations, okay? So you'll see that we have some little rules up here, okay? The first rule is going to be to simplify each side, okay? Basically, all that means is I want one base on each side. I want one base on each side. Okay? Really what I want then, step 2, is I want the same base. So sometimes I'll have that. That's really easy for me. And then sometimes I don't, so I have to do a little bit of work. Okay? And then last but not least, we could drop the bases, set the exponents equal. Okay? So that is the strategy. So we're going to go ahead, look at number 1 here. Would you agree that I have one base on each side? Yes, and is it the same base? Yes, okay, so awesome. Easy as this, okay? It's so easy. We can just take these exponents and we set them equal to each other. And that is literally all we have to do is solve that. How do I solve that? -1, duh. What is it? X is 8. That's it. That's my answer. I'm good to go. Can go back and plug it into the original and check that both sides are equal to each other if you want to. That's always a good thing to do when solving equations, okay? I want you to try number 2. Quickly. Okay, number 2, what are we doing? Yeah, we are just dropping the bases, okay? We have one base on each side. It's the same base. So I'm setting those exponents equal to each other. I love it. Good. Now what? Yikesies. We got to know how to solve these equations. We've been doing this since like 8th grade. Subtract the n, that works. Okay, there's multiple ways you could do this. You could move variables left or variables right. So if you did it a different way, don't erase it. Okay, so we get 3n plus 5 equals -7, and then subtract 5, 3n equals negative what? 12, and then divide by 3, and n equals -4. You got it. Okay, good deal. What questions do you have there? That's pretty simple, right? Okay. What about, though, if I get one that looks like number 3? Okay. My first question for you is, do I have one base on each side? Kind of a trick question, but technically no. Okay, over here to the left, do you see how we have 2 bases of 3? We need one base, okay? So this is actually a rule that we're expected to remember from Algebra 1, okay? And we have talked about it this year too. What are those 2 bases doing? What's the sign between them? Multiplication, okay? And the bases are the same, right? So what's that rule about when I'm multiplying the same base? When I'm multiplying the same base, what can Ow. What can I do? What can you do with the exponents if you're multiplying the same base? What'd you say? Add them. Good, Romeo. Yes, you can just add them. Okay, if you are multiplying the same base, you can add, I shouldn't say them, I should say the exponents. Add the exponents. Perfect. Okay, so on that left side there, I keep the base of 3, and then I literally can just add k plus 2, right? And then can I do like what I did in number 1 and 2? Absolutely. So you finish this one. You finish this one. Okay, what'd you do? Exponents equal to each other. Good. We got one base on each side now, so we could do that. Now what? Add up like terms. So on the left side, what do I got? What's k plus k? 2k. And now what? Subtract 2k. Okay, so I have 3k over here. I also need to add the 1 over. Good. I'm just going to do that all in one step. And then I need to divide by 3. And my answer is 1. Cool. Cool, cool. What questions do you have there? Jesse, you good? Okay, cool. Number 4. I don't want to do all these problems today because I don't want to be here all day, okay? And I want you to have time to do your homework. But let's just talk through number 4. What would you do here? Add the exponents on each side, right? And then you'd be able to do like what we did in 1 and 2, okay? So make sure if we see a problem like that, we know how to work with it, okay? Then we get to a problem like number 5, okay? So, would you agree with me on number 5? Do I have one base on each side? Yes, but is it the same base? It is not, okay? So that's my issue with this one, okay? So when this happens, here's our strategy that we're going to use, okay? We are going to look at both of the bases that we have, okay? In this case, 6 and 36, and we're going to ask ourselves which one of those two bases is smaller. 6, okay? So here's what I'm going to do. I'm going to go over here to the side, and I'm going to start writing out all my powers of 6 until I see both bases. So 6 to the first is 6. 6 squared is 36, and do I need to go any further? No, because I see both bases right there on that right side, okay? So perfect. This is telling me here I can rewrite both of these bases with a base of 6, okay? Well, the left one already has a base of 6, so I'm not going to do anything with that. I'm going to leave it. But the right side is 36. How could I rewrite that? I have it up there. 6 squared. Perfect. Now can I do what I did in part 1? Absolutely, because I have the same base on both sides, one base on each side. I set the exponents equal, and then I just solve it. Okay, how would I do this? Add 10. Divide by 2, and x is 6. Cool. That's it. That's the strategy. Okay, so I want you to go try number 6. Okay, what'd you do? Okay, so 2, we looked at those bases, 2 and 8, and 2 is the smaller one, right? So you went and probably wrote out your powers of 2, or maybe you just knew them in your heart. Okay, 2 squared is 4, and then 2 cubed is 8, and I don't need to go any further. Okay, so as Cody said, the left side stays the same, but the right side is going to be 2 to the third. Okay, how many of us made it to that step and knew how to set that up? Okay, cool. I love it. What questions do you have for anybody that didn't get it? Or hopefully we know what we did wrong. Okay, so now we just set the exponents equal, and what's the answer going to be here? It is going to be 10. It is going to be 10. Okay? Cool. Cool, cool, cool. Okay. Number 7. What is scary about number 7? What do we see on number 7 that makes us want to cry? Yeah, fractions. Okay? They're really, really, really not that bad. Okay? When we're looking at fractions and we're talking about bases, really the only thing I need to consider is what is that denominator? Okay? So if I look, base on the left is 7. Denominator is my base on the right, which is also 7. Okay, so I really don't need to write out my powers of 7, but I'll just go write out the first one. I know 7 to the first power is 7, right? Okay, so on the left side, once again, it's already good. It's got a base of 7. But here's now what I have to think with fractions, okay? I know 7 to the first power gives me 7, okay? How would I make that 7 shift downward to the bottom? You make it a negative one. Okay, so instead of positive first power, it becomes negative first power. That's just something we're expected to know. Okay, you might want to write that down. Okay, so negative exponents equal fractional answers. That's just important. We just got to know that. That happened on your quiz too, okay? Some of you wrote decimals, which is fine, but this happened, okay? And your calculator, if you ever want to double check yourself, just type that in, okay, and it'll work. So now can I do what I did? Or if I do my rules here, what do I do? Yeah, just set the exponents equal. How am I solving that? Minus 11. Divide by 4. So x is negative 3. Cody, are you doing okay over there? Some strange noises coming from that table. It's a little worrisome. Okay. All right. Cool. What questions do you have there? Nothing? Okay. We are going to hop down once again. I don't want to do all these. I don't want to be here all day. Okay. I know Cody does, but I don't. So number 9. The same strategy here, okay? But this one just looks a little bit more complicated. It's really not though, okay? So I look at my 2 bases that I have. You agree that I have 1 base on each side? Yeah, because I have 2 bases, one on the left, one on the right. Which one of those is smaller? The 3. So let's go do that. Let's go write out our powers of 3. 3 squared is? No. 9. 3 cubed is 27. Do I need to go further? No. Okay, cool. So, still doing the same thing, okay? We're still rewriting both sides, okay? If I look, the 27 can be rewritten as 3 cubed. Okay, but do you notice how that 27 already had an exponent of its own? 2x plus 6, okay? We can't just make the old exponents disappear into thin air, even though that would make our life really easy, okay? Instead, what we do is we put the old exponent in parentheses next to the new one. Are you with me there? Put the old exponent in parentheses by the new one, okay? That's all there is to it. On the right side, do I need to rewrite the right side? No, it's good. Already has it. All right, what are we doing? I had to go back and delete part of the video because we said inappropriate things. What? What are we doing? Dropping them down. Good. All right, now what? Distribute. What's the left side going to be? 6x plus 18 equals 2x. And now what? Minus 6x. So 18 equals negative 4x. And then divide by negative 4. And x is negative what? 4.5. Okay. Cool. Do we all agree with that? Yes? Okay. Ryan, you good? Jesse, you good? I like your hat. That's inspiring. Don't lose hope. Okay. Number 10. You want to do it? Do you want to do another one? Do you feel good about it? You sure? It's actually not that bad, to be honest. I like it. Okay. Go to number 11. Okay. Would you agree that we have one base on each side? Which one is smaller? 25. So let's go right at our powers of 25. What is 25 squared?
It's a big number.
Is it a big number? 625. That is a big number. Okay, is that going to work for me? No. If I keep going, am I going to ever get a number smaller than that? No, they're just going to keep getting bigger. Okay, so here is the deal, guys. Sometimes when you pick the smaller of the two bases, it's just not quite small enough. Okay, so we want to think even smaller than 25 as my base. Okay, but I want to think of a base that is going to get me 25 and 125 as answers. Okay, so when we think smaller than 25, what do you think? What's the first number that comes to your mind? Yeah, I think of 5 too, okay? If 5 wasn't the first number that came to your mind, if you tried something else first, that's fine. But you'll go write out your powers and you'll see that it won't work, okay? But if I go over here and write out the powers of 5, 5 cubed is
25.
5 squared is 25. 5 cubed is 125. And then I don't need to go any further, do I? Okay, so now I just have to rewrite both sides because once again, they have to have the same base. So 125 gets rewritten as 5 cubed parentheses y because he's my old exponent. Old exponents go in parentheses. And then the right side gets written as
5 squared.
Cool. And then can I do my exponent rule? Yeah, I just set them equal to each other. So 3 times y is just 3y equals 2. And then
Divide by 3.
my answer is 2/3, or if you want to do a decimal, 0.6 repeating, or 0.67. Okay. Girls, you good? Yeah? Okay. Cool. All right. Number 12, I would like for you to go try. Number 12. Go give it a go. Okay. I gave you some time. Let's figure this one out now. Smaller of the two bases is what?
2.
No, the smaller of the two.
8.
Did the 8 work?
No.
Oh, it didn't work, so we had to think smaller. What'd you try? 2. Did anybody try 4? You started 2. But it also didn't work, okay? So 2 is what we had to go with. 2 cubed is 8. 2 to the 4th is... Okay, so how'd you rewrite the left side? 2. Good. And the right side? Cool. And now what? Drop them down. Drop down those exponents. Distribute. So here 4 times 3x is, and over here, and then and that gives me
9x equals 6.
and then divide by 9, and your answer is
2/3.
okay, it is 6/9, but that simplifies to 2/3. Good. 2/3. Decimal equivalence of that is fine. It's 0.67 if you rounded it, okay? I think one of the Delta assignments, it wants fractions though, okay? So you may want to just leave it as a fraction, okay? Okay. Let's shoot down to 16.
16.
Does that work for you, McKenna?
Yeah, 14, 16, or 17.
Okay, we're gonna do 16 first. When I see a fraction, what am I looking at to find the base?
Negative.
What?
The denominator.
The denominator. Okay, that was a little scary, to be honest. Which one of those bases then is smaller? The 4. So go try that. Go try that, okay? I'm going to give you a couple minutes. I want you to try this whole problem because I know you're capable. So go write out your powers of 4, and if that doesn't work, we have to think smaller. All right, let's get going on this. The smaller of the two bases we already said was 4. Did that work?
No.
No power of 4 is going to give me 32. Think what? Smaller? What'd you try? 2. So we're going to go write out our powers of 2. I'm going kind of fast here. We only had to go to 2 to the 5th, right?
Yeah.
Okay, so left side first. Left side first. 1/4. How would I rewrite 1/4 with a base of 2? Good, Jacob. 2 to the negative 2. Okay, I look and see what what exponent gives me a base of 4, and that is the second exponent of 2. Okay, but I make that negative to make this a 1/4. Okay, that's how we do it. What is the left side still missing though? The 2x that goes in parentheses. Good. Okay, right side. Rewrite the right side.
2 left side, parentheses 4x minus 2.
Good. And now drop down those drop the bases, drop down the exponents and solve them. So negative 2 times 2x equals 5 times 4x minus 2. Solve it. What's the left side going to be? Distribute. So
Negative 4x,
on the right side,
20x.
okay? And then
Minus 20x.
you're fine. I'm just laughing. Okay.
Negative 24x.
Negative 24x equals
Negative 10.
negative 10 and
Divide.
divide by
Negative 24. And that equals 5 over 12.
5/12. Good deal. Negative 10 divided by negative 24 will simplify to 5/12. Your calculator will actually simplify that for you. Or you can. Oh, that is confidence right there that I like. Good. Good deal. Next page, you don't even think you need to do 17 or 18?
No, I think it's fine.
No,
You don't?
we're pretty confident over here.
Does everyone feel confident? You don't want to do 17 or 18? I mean, they're the same problem, but do you want to do one of them, Jacob? 17 or 18, or do you feel good? You're good? Ryan, are you good? Brianna, are you good?
Yep.
Okay. Sarah? Okay, we're moving on. What happens when our strategies that we just learned won't work? Okay, so number 3. Do you see how we have one base on each side?
Yeah.
Okay, and the smaller one is 2. And if I go write out my powers of 2, do you think I'm ever going to get 61? Probably not. Okay, so here's what we do when we can't use that. Okay, we take the inverse, and the inverse of an exponential is a logarithm. Thank you, Romeo. Good. Okay, it is a logarithm. So what we want to do, you want to get the exponential on a side by itself and then just take the log, okay, and solve it. So here we go. Is my exponential on a side by itself? Yes, 2 to the x is on a side by itself. So here we go. LOG. The base is 2 of 61 equals x. And you just took a quiz over how to type that left side in the calculator. So you should be good on that. Tell me though, how do you type it in? Gotta have the log button. Log of 61 divided by Log of 2. Log of A divided by log of B. What is that? 5.9? 5.93? I'm going to round to the hundreds place. Okay, cool. 5.93. That is it. Okay, are we good there? Number 4. Give it a go. Give that one a go. You can do it. Okay, how'd you set this up? Log base 8 of 92 equals m minus 7. Perfect, perfect, perfect. Okay, the exponential was isolated, so we set up our log. When you type this left side in, what do you type in?
Log 92 over log 8.
Good. Log 92 divided by log 8. What is that?
2.2.
2.17. And last but not least, am I done? You have to add 7 because we're solving for m. And when you add 7 to 2.17, what do you get? 9.17 equals m. Perfect. You could always go plug that back in. That's always a good thing to do to make sure it works. It does. Okay. Any questions there? Okay, what happens like on number 5? Is that exponential isolated? No. How would you isolate that? What is the exponential? 7 to the n. So what do I need to get rid of? The 4. And how are you gonna move that 4? What's it doing? It's multiplying. So you divide it. Always use inverse operations to isolate, okay? The inverse operation of multiplication is division, okay? The inverse operation of subtraction is addition, okay? We just have to know those. That just makes our life easy. So 7 to the n equals 37. And then you just solve it like we did on number 1, right? So quickly, let's do that. Really want to know what they're hammering over there. You all right? Okay. It's okay. That's good. Okay, type in that left side. What do we got? Huh? Did you type it in? No. 1.86. Okay. Okay, once again, I don't want to do all these, but let's just talk through a couple. Number 6, how would you isolate that? Add the 5 over, and then solve like normal, okay? Number 8, how would you solve that one? Yeah, divide by 10, okay? That would be the first step, is just divide by 10, and then you'd be good to go. I do want to do number 9, because what is weird about number 9? It's got a E. What is E? It's like what? Yeah, so it's like irrational. Not improper, but irrational. Good, okay? It's kind of like pi, right? It's just a number that is super, super long that we really don't want to memorize, okay? So when we're talking E's, it's still the same strategy here, okay? We still want to get that E by itself, so let's do that real quick. How would I get that E by itself? Before you divide, you'd have to subtract the 2. So 2e to the x equals 90 minus 2. Huh? 88. I like the accent. Okay. Then what? Divide by 2. Okay. So e to the x equals 44. Okay. I'm glad that's going to be in the video. Okay. Oh, she's on to something. Okay. So we have our exponential isolated. We know we have to take the inverse, but the inverse of E is, what did you say, Allie? ln, natural log. Okay, so instead of writing log, you write ln of the 44. No, the e goes away because we're taking the inverse of it. Natural log of 44 equals the exponent, which is x. Okay? Your calculator has a natural log button, so do not use the log button. It will not work for you. Okay? You literally just type in ln 44, enter. What is it? 3.78. That's it. Okay. Number 10. Try number 10. It's a little different. Give it a go, though, because we got to know what to do with these E's. For some reason, the letter E gives a lot of people some unnecessary stress, and it shouldn't. It's not difficult. Just a different base. Okay, what'd you do? First step is to isolate the base. Is that isolated? Or isolate the exponential? It's already isolated, so what'd you do?
ln 87
I ain't got nothing up here.
equals 3x minus 5.
Okay. That is perfect. That is how we do this. Okay. What is natural log of 87?
Let's hear it. No, what did you get? No, I did it a completely different way. You got it. This is all you. You've only wanted
No,
to be
I'm
good for
alright.
6.
I'm alright.
Chloe, what did you get?
I didn't do it right.
You didn't do it right. Okay. Can you do it right now? What is the natural log of 87? Can we just type that in?
4.46.
4.46. If we didn't do it right, do we know what we did wrong so far?
Yeah.
Okay. So then you would, now what?
5.
Add 5. You get
9.46.
equals, and what's that going to give me? 3.15? That's what you got, Cody, on the first try?
Yeah.
I like it. You're smart.
Thank you.
Yep. Okay. Cool. Any questions there? Nothing? Nothing at all? Do you think you'd be able to do one like 11 or 12? I don't know if we need to, but let's at least talk through how to isolate one of the two. Which one do you want to do first? Or just do? We don't have to do both. 12? Okay. How would you isolate 12? Add 3. So you'd get 8 times 11 to the 7k equals 216. And then you would divide the 8. And then that would give you, you don't know, 27. So then you would take log base 11 of
27.
equals
7k.
7k, the exponent. Okay. I tricked you into doing this whole thing, but we're just going to keep rocking and rolling through it. How would I type that left side in? Log 27 divided by
11.
log 11, which is
I don't know.
1.37 equals 7k, and then divide by 7, and what is that? 0.19, and that would be your answer. Isn't that kind of cool? Kind of fun? Cody thinks it's fun. I think it's fun. Best day of math ever, right? For real. Okay. Any questions that you have before we do our homework? Nothing? Okay, you have almost a full 30 minutes to do your homework, so let's go ahead and get that done. Ready, set, go.